The use of electricity in South Africa is crucial to support day-to-day activities in homes and businesses. Electricity is transported within an electrical installation in these homes and businesses. Electricity is generated from power stations and then transmitted via transmission lines to different distribution systems. These distribution systems feed domestic, commercial, and industrial consumers. The generation, transmission, distribution, and consumption of electricity must be performed in an efficient and a safe manner. For us to ensure that safety is adhered, we need to establish standards within the industry. These standards should deal with the following: design of installations, construction of installations, selection of components used within installation, inspection and testing of installations, certifications of installations, and verification of certified installations by third parties, approved inspection authorities. All certification of electrical installations should be done by competent people. The certificates issued by these competent people should be valid and traceable. It is also important that equipment used for testing and inspection of electrical installations should be accurate and regularly calibrated. The sum total of the above will then cumulate into a regulated safe environment within the industry. In South Africa, the Department of Labour is responsible for ensuring this environmental through Occupational Health and Safety Act, electrical installation regulations, electrical machinery regulations, and the incorporated standard. It is therefore imperative that students and trainers in this industry be aware of the regulatory framework. My opinion is that this course is an attempt to bring performance and safety standards to the attention of the students and trainers. This guide provides assistance to electrical workers and trainers in need of quick access to information on electricity. The information in this course is by no means meant to replace any previous or existing information on the explained subject. Simplified, user-friendly advice and explanations are presented with colorful diagrams and photographs. Sections and text are laid out in a logical order and a sequence that facilitates learners. To ensure an electrically safe installation, electrical systems and equipment must be installed and maintained in accordance with the manufacturer's instructions and have to be complied with the requirements of the South African National Bureau of Standards. It is beneficial to manage electricity efficiently, but harmful when used incorrectly. Always think safety first and test before you touch. Section 1. Graphical symbols for electrical wiring diagrams. Symbols and descriptions. The wiring of electrical circuits and fault finding can be simplified when circuit diagrams and graphical symbols are known, understood, and used. Different types of symbols for electrical diagrams are used nationally and internationally in handbooks, catalogs, pamphlets, etc. In this course, the following recommended basic graphical symbols represents various electrical components and their accessories. Okay, now today we're going to be using SimuRelay to simulate these circuits and how it works. I'll give you a whole rundown as this course continues to show you how this software works so you can design relay-based circuits and whatnot. I'm using the free version of this application because the time delay stuff don't exactly work, but I'll show you another way to do it, and after just paying for the full version you can have access to everything. Okay, let's actually go from the beginning of this circuit. I've designed this circuit on SimuRelay, which is a typical direct online motor starter, which is the first circuit or the first connection of the circuit that I recommend you learning, because everything from this course going on is going to be based on this circuit and how it's connected. So we have our three phases here. Phase 1, phase 2, phase 3, which is coming straight from the supply. Okay. From there, it goes into your 3-pole disconnector or your circuit breaker, which is Q1. We'll name it Q1 for now. We can change the name and all that kind of stuff, which is this is your main circuit breaker. Out of your main circuit breaker, you get your contact 1. Now, your contacts, you can arrange them and put them as many as you want, depending on what you want to do or what you want to isolate and power and energize and all that. Contactors are simply just relays. They're simply relays. They just make you energize the coil and it makes contacts to the relays. Because of that, you have 3 points. You can energize different circuits. You can power different things. It's up to your imagination on what you really want to do. But these are mostly made to energize 3-pole three-phase motors basically. But anyway, this is your main contactor or your first contactor that you'll learn. After your contactor, it goes to your overload relay, which is there to prevent further damage of the motor, which is this one, in case there's any trip condition or earth faults or anything like that. So if your earth leakage is breaking down or something like this bad boy is there to prevent anything from stuffing up. So that's your main part of your DOL. So let's go to the control circuit. Now, because I don't have a neutral, I'm probably getting this thing from a delta connection. If it was star, I would have a neutral. I would just use that. But because this is, I'm getting it like this, I'm going to take power from line 1 and line 2. And I'm going to connect it to another circuit breaker, which is just a 2-pole circuit breaker. Why I'm designing it like this is because I want to isolate the control and the control and the main power, the control and the main basically. So if this is off, I can still test to see if my contactors or my switches and stuff like that is working, which is will be very useful when you just want to see if the conditions of the things are working. Now, remember, this looks simple right now, but it can get to a point where it's complicated, where you have multiple contactors that must be sequenced and it must be started in a certain sequence. For instance, maybe you want the main one to switch on, then the main must switch the star on, then it must change to delta, then maybe after a certain amount of time, motor 2 must turn on, and or whatnot. Now, if your connections and stuff are wrong and you did something wrong on this, you could potentially cause like a horrendous short. That's why we put these protection circuit here to protect the motor, and all these other stuff will trip in case of that. But anyway, so we have 2 circuit breakers. We have a double pole here and a triple pole over here. On this side, we have our emergency stop. As you can see by the look of the symbol, this is emergency stop. So if there's any problems, anything that you notice that something's going wrong with the motor, you click that in, and then it would disconnect the contactor or disconnect the connection, and your control circuit will be unable to power or energize the coil in the main circuit. So this is an emergency stop. Always have one, always put it on. Highly recommended. You'd be good as daisies with that. Okay, cool. After the emergency stop, we have a stop here. So if you want to de-energize your coil, you need a stop button. Without your latching system over here, you're gonna have like press button stuff where you would normally see it in cranes or something like that, where you want the motor to move just a little bit so much to the left and the right. You would use it like this without the latching system. But then if you want to latch it or something like that, you can put the latch on, this is the latching circuit or the retaining circuit here, and this will keep energized when this contactor is energized. This latch will close as well, because this is part of the same contactor, and then it will keep the motor running if it's supposed to stay running until you want to switch it off with the stop or the emergency stop. Okay, cool. And this you can pretty much add anywhere in line of this circuit, but this is the overload relay, right? This is the normally closed on the overload relay. So when the overload relay notices a trip condition, this circuit will open and there'll be no power being supplied into your control circuit. Thus, for your main contactor will not open. And when you reset the overload, then this comes back on. And then if it trips again, you just know that the fault is somewhere below the overload relay. And then coming here is the main contactor coil. When the coil gets energized, it closes the contactor, and then it supplies power through there. So I'm going to run the simulation over here, and I love about this program is that it color codes everything to see. So let's put in a situation right now where I'm not going to supply power to the motor. I just want to test if my control circuit is working and see if the motor is going to work. So I'm going to turn on power there. And as you can see, the red is where I'm getting my live coming through. Blue is neutral, because that's what the colors that are here. Maybe it could have been gray or whatever. Cool. Now we have power supplying to here, and we have a nice connection on the other side. Let's see what happens when I press start on the motor. I hit start. Notice the latching circuit energized as well and closed from normally open to go into closed, and my contactor closed. Now the motor should be spinning, but because I disconnected power from there just to make sure this is working first, to see if this is the wiring, everything's correct. Okay, I'm gonna hit my stop and let's see what happens now. So I hit stop and contacts go open. Motor is not running and cool. Let's test it with the emergency stop as well. So I'm gonna hit start, the contacts made, everything closed. Now I hit stop, or the emergency stop, and let's see what happens. Emergency stop kicked in, no power. So even if I hit the stop, even if I hit start, it ain't doing anything until I disengage the emergency stop. Okay, I'm pretty happy of what's happening with the control circuit and the main circuit. I can see what's going on. I don't see any noticeable shorts or anything there, so I'm gonna supply power now to my main circuit. Okay, so now when I hit start, everything is energized. The motor is turning in an anti-clockwise way. I don't know why, it should be clockwise, but it's turning. When I hit stop, motor switches off. It's all good. So now let's test the trip condition with the overload relay. So I'm gonna turn the motor on. Everything is running fine, everything's going well. Then I tell it, over relay, switch on. As you can see, the overload relay is on. It has disconnected power from the contactor and has opened itself here at the bottom. No matter what I do, no matter what I press, it will not switch on the motor again until I disengage the overload relay and start it again. So when I press this overload relay button, which is like a red button on the overload relay, when I hit it, it automatically trips the motor, and then it opens the connection and then won't allow power to come through. Okay, that is your basic direct online starter. Like I said, this is something that write it down, memorize it, and know it, because every single motor base or induction motor base circuit is based on this circuit over here, direct online. If you want to do forward and reverse, it starts with direct online. If you want to do sequence one, it's direct online. If you want to power slip ring motors, it's also direct online. Even single phase forward and reverse is also direct online, or kinda. It's kinda like direct online. But all these connections, all these circuits and stuff that you learn in this course will stem on this basic motor control. And then the cool thing about this, once you learn this like this, you can also add like an electronic sense, where you can put like relay control switches with PLCs or with Arduinos or anything like that to control these switches over here, and you can have something that's very automatic. With designs like this, I've done it in smart homes and stuff like that, like I said, using Arduinos. I also used it for like light control circuits, but it all stemmed from me learning what direct online and everything is. Thank you. We have just completed chapter 1 of this course. I'm going to check you guys on the next one.